Hello students, welcome to Unit 1 Notes, Section 1-6. I already completed the warm-up, so feel free at this time to pause the video and check over your answers. Try to do this on your own first, and then look over to see if you receive the same result. All right, continuing on to save time. In 1-6, we're going to be learning about angles and their measure. Not only that, but how to name them. So here's some of the topics. Let's see, we're going to focus on acute, right, obtuse, and straight, so we're going to define them. Congruent angles, vertical angles, adjacent angles, complementary angles, and supplementary angles. And we are also and all of those are special angle pairs. Okay, so finding angle measures. Here I created two different angles. You'll see one right here and then one below. In this one, we have angle B, right? So this right here, the location where B is called a vertex. It's the point at which the angle is changing. Angles are formed by one ray and two rays with the same endpoint. So I'm going to ask you a question probably on a quiz. How are angles formed? And they are not by intersecting lines. Its true definition is by two rays that share the same endpoint that are coplanar as well. So here we have angle B. We could also call it angle 1. We can also call it angle TBQ. We can also call it angle QBT. So I'm going to write the four ones down that we're able to call them. Angle B, angle 1, using the number on the center of it, angle BQ, and angle, I'm running out of room, angle QBT. What we can't name it is this. We can't say it's angle TB. We can't use two letters. It can't be angle TQB because it has to go in order. Look at what TQB does. TQB doesn't go in order. It has to be centered on the vertex. Notice that B, sorry about that, B and B are in the center of the three letters because it's the vertex. Okay, so you have to use three letters or one letter only. You can't use two, can't use four, all right, or we can use just one number. So TQB, what's another one we can't do? Feel free to write these down and cross them out. We can't do QTB, can't do that one. Can't do BTQ or angle BQT. Cross those out. Those are not options. Okay. In geometry, it's just as important to write the correct items down as it is to write the incorrect ones down and cross them out. So when we refer back to them, when we're studying for a quiz or preparing for a quiz, we know what we can and can't do. All right. Another thing you can't do, I don't know, I'm going to get crazy here. Q1. That's not an option. We don't call it angle Q1. You can't mix letters and numbers when we're talking about angles. Okay. And here we have it. It's formed by ray BT and ray BQ. All right. Okay. It looks like they also listed all the information I did. Vertex B, and they wrote the four ways you can name it. So I want you to try. Feel free to pause the video here. And I'm going to start writing these out, okay? But you can try them on your own if you pause the video for a second. So I'm going to go with probably the easiest one, angle 3. That one's pretty easy. And angle P, angle ZPR, and angle RPZ. And those are our four options. Okay? All right, so let's go on to the next one. Look at this. I don't know if any of you have ever been to Six Flags or on a roller coaster, but steel beam roller coasters have a whole bunch of angles. So here's a real life example. Notice that we don't have just one angle here. How many angles do we have? Take a second and think. How many angles do we have here? I bet you some of you said 1. I bet some of you said 2. And maybe some of you even said we have 3 angles. And the correct answer is we have 3. How so? Well, here's one angle. AEC is one angle. CED is another angle. And also AED is the third one. Notice that AED is composed of both AEC and CED. So it says name CED in 2 other ways. Well, CED, we can name it angle DEC going in the other direction, and we can also name it angle 2. You know what I cannot do? We cannot name this angle E, which kind of contradicts something I said before. Why can we not name it angle E? Well, that's because angle E could be this angle, or this angle. Could be all of this. So E is not specific enough for me to be able to use one letter. Let's go back to the last one. 3 we could use, and we could use P, because P was only one angle. It wasn't shared. But this one is shared, therefore we're not allowed to use its nickname, or its, a quick way of saying it would be E, because we have angle AEC, CED, and DEA total. We have 3. Okay? So look at, I just answered the next question here. We cannot name it angle E. All right. And let's see. What's another name for angle 1? Angle 1 also has the name angle AEC or angle CEA. All right. Oh, you know what? That was the question above. I didn't even notice that it was asking that question. I found that weird that it didn't ask that question, but there is the answer to that question. Angle AEC and CEA. Notice all of my letters are capital. I'm not using any lowercase letters because that's not a thing when we're talking about angles. Okay? All right. Next one. One way to measure an angle. So this is classifying an angle. We can classify it based on its angle measure. We shouldn't really be making assumptions, but for this example, we will. We're going to say that this is a right angle. Well, this isn't an assumption because it actually has a right angle drawn in. It's a tick mark that is in the shape of a box. Here, this one, if it's less than 90, we call it an acute angle. Here, this one is obtuse. And this one you're probably not too familiar with. We have acute, right, obtuse. But what happens when it equals 180 degrees? That's what we call a straight angle because it forms a straight line. So an acute angle is less than 90. It's not equal to 90, so we're not going to use the equal sign, right? We're not going to say it's less than or equal. It's just less than. But what does it have to be greater than? Well, it can't be 0 or else it would just be a ray. So it's between 0 and 90 degrees, which would make an obtuse angle between 90 degrees and 180 degrees, because it can't be 180 or else it would be a straight angle. And so a straight angle is exactly 180 degrees, and a right angle is exactly 90. And there we are. So we can call an angle, we can classify an angle as being an acute, right, obtuse, or a straight angle. Now it looks like I forgot a letter here. There we go. All right. So the next thing we're going to focus on is the angle addition postulate. Remember what a postulate is? Remember what a postulate is? It's an accepted statement of fact. So we're going to accept this as fact. If point B is in the interior of AOC, here's point B, then the measure of AOB, this one, plus the measure of angle BOC is equal to the measure of AOC. All this is saying is part plus part equals whole. And that makes sense. 3 plus 5 is 8. It will always be 8. So we can do the same thing with our angle measures. So I'm going to make up fake angles here. I'm going to say that this is 80 degrees, and I'm going to say that this is 40 degrees. So I'm literally going to write this out. Measure of angle AOB plus measure of angle BOC equals measure of angle AOC. Therefore, 80 degrees when I substitute in for it plus 40 degrees equals, in this case, 120 degrees. So I could say that the measure of angle AOC is 120 degrees. That is how I would use my postulate. Notice what's different. I'm writing the letter M before it. Why? Because when we refer to a measure and we want to set it equal to something, whenever we use an equal sign with angles, we always use the M before it because it's a measure. So it's different than naming the angle. Naming the angle, it would just be angle AOC, like they did before. The measure, though, with an equal sign, you have to use the letter M. All right, the next one, if it's a straight angle, then it has to add up to 180. Well, this makes sense, right? Because if a line is 180, then let's say 30 and 150 would have to add up to 180. So yeah, we're definitely gonna do 30 plus 150 equals 180. Here's what I would like them to do is put a degree symbol. We should be using degrees when we write them. Measure of angle AOC equals 120 degrees. All right. So let's classify our angle. This one appears to be, well, I'll give you a second. Feel free to pause it. Try to do these on your own if you can, these 5. But I'm going to save time on the video, I'm going to do it right now. Okay. So here, this one appears to be an obtuse angle. This one appears by appearance, appears to be a right angle. This one appears to be an acute angle. This one appears to be a right angle. Again, I'm basing this on the measure being about 90. And then this one appears to be an obtuse angle. If I ask you on a quiz, I will make it very apparent that it is a obtuse angle. I won't make one that's 91 degrees. Like, I won't make it look like this and say, is that right? Or is it obtuse and trick you? It will be very clear it's either right, obtuse, or acute if I ask a question like that on a quiz. Because again, we're judging by appearance. We shouldn't really be making assumptions, but if we're going to make assumptions, then we need to make sure that we make it apparent. with those assumptions. Okay. Next one, we're actually going to use the angle addition postulate. So what is the measure of TSW? So the question here is, what is the measure of TSW? I'm going to put it in X here, and I'm going to put a degree just so that we know that X is not a letter like S, R, T, or W. So it's not a point. It is an angle measure that I don't know. So X degrees. What I do know is that RSW is 125 degrees, and I know that RST is 50 degrees. So I'm going to put in RST, that is 50 degrees. That's this one right here. And then in orange, I'll put, let me color coordinate this. In orange, I'm going to put the 125 degrees. So RSW, this one right here, is 125 degrees. So I don't want to make it too complicated, but I'm going to just say that the measure of angle TSW plus the measure of angle RST is equal to the measure of angle RSW. And I'll show you that. So TSW, this angle, plus RST, this angle, is going to be the whole thing RSW. So if I fill in my variables, I'm going to put X here, X degrees, and we're going to say plus 50 degrees equals 125 degrees. And I'm going to just take away 50. I'm going to say that X is equal to 75 degrees. Therefore, the measure of angle TSW, I need to answer my question. My question did not ask me what X was. It asked me what the measure of angle TSW was. So I always need to answer appropriately. Whoops. And answer in a full sentence, a mathematical sentence. The measure of angle TSW is 75 degrees. Now, some of you are watching this video and going, Mr. A, I mean, come on, that one's 50. The other one has to be 75 for it to be 125. That's fine. You didn't have to set up an equation. What I'm trying to show you is that this could get very complicated. We might have variables in here and variables in here and variables here, and it's going to be so complicated we are going to have to set up an equation using the angle addition postulate. We're going to have to do whatever this is plus whatever that is in terms of the variables, and then set it equal to a new set of variables, same variable, but a set that is equal to the set, these other two smaller sets. Okay? Again, for this one, we're going to say the measure of DEG is 145. That's this one. And we want to find GEF, so that's X degrees. But what I do know is that this whole line, this whole angle DEF is a straight angle, which makes it 180 degrees. So this one is 180 degrees. I'm going to say that the measure of angle DEG plus the measure of angle GEF is equal to the measure of angle DEF. So the measure of angle DEF is 180 degrees. I don't really need parentheses. I don't know why I'm using them. Here we have X degrees, and here we have 145 degrees. So to keep this as simple as possible, I take away 145. And X equals 35 degrees. So the measure of angle GEF is 35 degrees. There we are. Again, you probably said, Mr. A, the only value that could be is 35. So if I just put in 35, it'll equal 180, and that's fine. But what happens when we have variables here, variables representing the whole angle DEF, then it could get much more complicated, and we're going to have to set up our equation using the angle addition postulate. Okay? For this one, we have something unique happening. We have angle AOB, we have angle BOC, we have angle COD. Then we have these little lines here. I'm going to clean them up. This is a very blurry picture. But these mean that these angles are congruent. Therefore, the measure of angle AOB is equal to the measure of angle COD because angle AOB is congruent, look at my congruent symbol, to angle COD. So knowing that they're equal, I'm actually, let's see, we have AOC is given, and we want to find BOC. Okay, so what we first have to do, here's our strategy for this one. Because we know AOC is equal to the measure of angle AOB, let's substitute in for both of the angles. So what I did was I took AOB, which is 2x plus 8, and I substituted in for this side. And then I took 7x minus 2 and substituted in for this side. Why would I do that? Well, if I solve for x, I can then evaluate x in what I'm trying to find for BOC. Oh, you know what? Do I even need BOC? I actually don't need BOC. This is kind of, wait, AOC, AOB, I'm looking at the wrong angles here. Okay, good. I'm glad I didn't keep going further. Let me erase this. What am I given? I'm given AOB, I'm given AOC. Okay, my apologies. I'm erasing this. You know what? I can keep some of it. The measure of angle AOC is actually composed of angle AOB and BOC. Here, I'll go back to it. I know I'm probably confusing right now. Measure of angle BOC equals this. Okay, let me clean this up. So what I'm saying here is measure of angle AOB plus measure of angle BOC is the measure of angle AOC. AOB plus BOC is equal to AOC, which is the whole thing. So part plus part equals whole. And now I have all these variables here. I'm going to substitute in. So AOB is 2x plus 8. And then I get BOC, which is 3x plus 14. And then I get AOC, which is 7x minus 2. I do some algebra. So I combine like terms. I'm going to move 5x over. Again, however you solve your equation is up to you. I'm going to add 2. So I'm going to get 24 equals 2x. Solving quickly. Feel free to pause the video if you need help with it. Maybe if you need help following. Just trying to save time. So I get x is 12. If x is 12, I can check my work quickly. AOB and COD should equal each other. Oh, I don't have COD here, so I can't do that. All right, let's just go on to the next step. I'm going to evaluate, use the diagram to solve for x. Oh, we're done. We didn't have to actually find any of these angles. I could evaluate for an angle if I wanted to. All right, let's see what this one's asking. It wants AOB plus and BOC and COD In this one, I just have to set AOB and COD equal to one another. We don't have any other information. Okay, this is a new problem. It's unique. So X won't be the same thing only because it's using the same diagram for a new example. So don't worry if you don't get the same thing. But I don't need at all to use BOC because it's not setting it's not setting all of these equal to something. It's just setting AOB equal to COD. So 4x minus 2 equals 2x plus 14. So I'm going to, let me just take away 2x from both sides. Plus 2. Divided by 2. X equals 3. All right. So again, you won't get X being the same thing because these are just unique problems. All right. So the next part of our lesson, the other half of it, is identifying angle pairs. So we have two intersecting lines, and what happens when they intersect? We actually get four angles. One angle, angle 1 is formed by 2 rays. Angle 4 is formed by 2 rays. Angle 2 is formed by 2 rays, and angle 3 is formed by 2 rays. And here's what's really cool. 3 and 4 are going to be congruent, and 1 and 2 are also going to be congruent because vertical angles, oh wait, do I want to get into that? I guess we can. Vertical angles, so angle 1 is congruent to angle 2, meaning that the measure of angle 1 is equal to the measure of angle 2. And angle 3 is congruent to angle 4 because the measure of angle 3 is equal to the measure of angle 4. Vertical angles are congruent. They are formed, and you need to know this, the definition of it, two angles whose sides are opposite rays. So here, 4 has ray here and here. What is opposite to this ray? This ray. What's opposite to this ray? This ray. Therefore, 3 and 4 are formed by two sides. There are two angles whose sides are formed by opposite rays. They are not formed by intersecting lines. So if you see that on a quiz, don't pick that as an answer because, again, this is the specific definition for vertical angles. They actually make a V. That's how I remember them. Adjacent angles can be are side by side. They can be supplementary. They don't have to be. See, 1 and 2 are adjacent. 3 and 4 are adjacent. They're described as two coplanar angles with a common side. Here's your side. They are also coplanar. They're in the same plane. And a common vertex. No common interior points. That means that if I put some points here and some points here, they don't have anything in common. They don't share the same space. So what happens when something is adjacent and supplementary? Let me put a little star here. Adjacent, supplementary angles have a special name if they are both adjacent and supplementary, they have a special name, and that is called a linear pair. All right. So just put that, add that little definition. I don't know if it comes up in our lesson, but if you need to add it, it's right there. Okay. All right. So again, these are both adjacent, but if they are adjacent and supplementary, they also have a special name called a linear pair. Complementary angles, they complement one another. Think about this, complementary, supplementary. Some students mix this up. 90 degrees, 180. 90 comes first on the number line. C comes first in the alphabet. 180 comes later on in the number line. S comes later on in the alphabet. So 90, 180, C, S. That's how you can remember your complementary and supplementary angles. So they are two angles whose measures sum 90 degrees. They can be adjacent complementary or they can be just complementary. It's any two, they don't need to be connected. Same thing with supplementary. Can be connected, they do not have to be connected. Okay? Again, adjacent supplementary angles, this is also called a linear pair. It's a cool name for it. Put a little note, another little note here. Here's a second note. Complementary and supplementary are two angles only. Not one, not three, not more than that. So a lot of times students look at three angles that add up to 180 and they go, oh, that's supplementary. No, 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 it's only two, only two. I don't know what to do here. Maybe highlight it in a special color. Whoops, whoops, my bad. Oh, it didn't pick that up. That's weird. Okay. Okay, we talked about congruence. So again, if we're using equality, we use the angle, the measure of the angle, 1 equals measure of angle 2. If we're talking about congruence, we leave out the m. Okay, so here's a bunch of ones. Angle 1 here is congruent to angle 2. Okay, notice that this angle here, let's name it, I don't know, angle 3. Oh, let me find a color that stands out here. 3 and angle 4 are congruent. Notice the tick marks. Remember, hash or hatch marks is another name for it. The tick marks here, 1 and 2, we only have one tick mark. 3 and 4 have two tick marks. It does not matter the amount of tick marks. If we want to use 4 tick marks for 1 and 2, we could have, but we cannot then use 4 for 3 and 4 unless 3 and 4 are also congruent to 1 and 2. So the tick marks are to be clear to the reader that we are specifically talking about these two angles and then these two, but the tick marks mean nothing in terms of how many we use. Okay, extremely important. This is extremely important. So, whether you draw a diagram or use a given diagram, you can make some conclusions directly from the diagrams. You can conclude the following, okay? That adjacent angles are adjacent. that adjacent supplementary angles are adjacent supplementary and that vertical angles also exist. Here's what that means. That means that nowhere will we give you a diagram that instead of having two two opposite rays like this, that will adjust a ray just a little bit like that. Do you see what I did there? I tweaked it a little bit. This won't happen. We're not trying to trick you. If we did do that, if we made that little adjustment, I hope you can see it there, like right there. It's like that weird, it's not perfectly in line. It's not opposite ray. Not opposite ray. We are not going to do that, okay? This won't happen. So you can always assume that vertical angles are always vertical. Unless we state that this is congruent to this, and then we say that these are not congruent, we might use like different tick marks, like 1, 2, and 3. If we use 1, 2, and 3, then you do need to assume that they are not perfect. Okay? All right. Adjacent supplementary. We're not going to make a line like this where it has like a line here, and what you don't see is like a very slight line off to the side of it where it's not actually connected. Like, let me do this. Let me break it up like this. Okay, we're not going to do something weird like that with a little gap. It's going to be exactly the way it needs to be. Okay, and adjacent angles and adjacent supplementary fall into that category. Okay, here's what you cannot assume at all. Actually, the bell just rang, so I'm going to stop the video here and I'll continue it on in a second. Hello students, welcome back. Sorry about that, the bell rang and I had to pick up the video at a different time in a different spot. But just quickly, I think we left off where we were explaining the three things you are allowed to assume, one being adjacent angles. So they're not going to be crooked like that. If they're adjacent, they will be connected and there will be no gap in between them. Adjacent supplementary, same thing, just with supplementary, no gap in between them. And vertical angles, they won't be drawn with that little curve as if they're not perfect. So if drawn, the diagrams can be assumed to have these three things. What cannot be assumed is this. Angles or segments are congruent. So in its simplest form, if you have a line segment and I have this ABC, I cannot assume that this is congruent to this. It might look it, it might be close, but we can't make that assumption, okay? So we are just going to assume they are not. Assume they are not congruent. Because if they were, they'd be marked. The second thing is that an angle is a right angle. Again, we cannot assume that a right angle exists. All right, so whoops. We cannot assume that this is a right angle. Right? It might be, but so we're going to assume it is not right. Well, we just can't assume that it is. So let's not assume that this is. Let's not assume this is a right angle without markings. So for this one, let me change it to let's not assume. Let's not assume these segments are congruent without markings. Okay, and the last one, that lines are parallel or perpendicular. So let's not assume parallel or perpendicular without markings. Okay, and I'll use my parallel symbol. So if we have something drawn in, they might look it, they might look it, but we can't make that assumption. Without any right angles or any lines to say that they're parallel. Okay? All right, example 4, identify pairs of numbered angles that are related as follows. Again, it says pairs. So we are looking for pairs of angles. So complementary, let's see, we have 90 degrees. So it looks like to me angle 2 and 3 are complementary because the two of them add up to 90 degrees because they have that marking there. So angle 2 and angle 3. You want to know what? 3 and 5 are vertical, aren't they? Look at 5 and 3, they're vertical. So I can throw in a little tick mark here and a little tick mark there. So wherever I see 3, I can use 5, and wherever I see 5, I can use 3 when talking about the angle measure, okay? So if 2 and 3 are complementary, so are angles 2 and 5. We just we substitute in 5 wherever we see 3. All right. Supplementary. Remember, it's 2 angles, not 3. So what 2 angles add up to 180? Well, looks like here we have 4 and 5 that will add up to 180. So for supplementary, I'm going to say angles 4 and angle 5. And again, wherever I'm able to swap out a 5 with a 3, we can do that. But take a look at this. That is also supplementary there. So we're going to say angle 4 and angle 3. We didn't really need to swap it out because really it was stationary. We could see that we could use 3 as being the angle with 4, or we could use 5 with 4. All right, again, yes, 1, 2, and 3, all 3 of these angles do add up to 180, but they are not supplementary because it's only based on 2 angles, not 3. Vertical, well, we already said that 3 and 5 are. Notice that 4 is vertical to 1 and 2, but it can only be one angle, so in this case, we can't use 1 and 2 collectively. So 4 with 1 and 2 are not an option, only 3 and 5. So we're going to say angle 3 and angle 5. And then adjacent will, let's see, 1 is adjacent to 2, 2 is adjacent to 3, 3 is adjacent to 4, 4 is adjacent to 5, 5 is adjacent to 1. So there's a whole lot here. We're going to say angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4, angle 4 and angle 5, angle 5 and angle 1 are all adjacent. All right. So name 2 pairs of angles in the photo below that are adjacent. So I'm going to say, I'm just going to pick one of them. I'm going to say angle AFB and angle BFC are adjacent. Let me see. I'm going to run out of room if I do that. Whoops. And again, you could have done this angle with this angle. We could have done these two angles. We could have done these two angles. Okay, I'm not drawing tick marks. I'm just showing you the angle. All right, so we could have done this angle with this angle with this angle, or this angle with this angle. But they all have one thing in common, and that's vertex F. So F would have been in the center of all of these that we would have written out. Okay? And if the measure of EFD is 27, so EFD is 27, find the measure of AFD. So AFD, the question is, how much does this add up to from here to here if that other piece is 27? Well, 180 degrees, because AFE is a straight angle. Take away 27 degrees, 80, 70, 60, 50, 153 degrees. So the measure of angle AFD is 153 degrees. And I'm just basing that on the fact that this is a straight angle. That's the only information I needed to solve that problem. All right, next one. What can you conclude from the information in the diagram? There is so much to conclude. You can conclude all of your adjacent angles, right? So adjacent ones, I'm going to say 1, 2, 3, 4, 5. Adjacent angle 1 and angle 2, angle 3, and, angle 2 and angle 3, angle 3 and angle 4, angle 4 and angle 5, angle 5 and angle 6. Those are adjacent ones. What ones are supplementary? So supplementary, angle 4 and 5, angle 1 and 5. These are also, let's see, 4 and 5, 1 and 5. I don't see any other combination. So I can also say that these are also a linear pair. So let me erase that. Let me put this above it. So supplementary, let me do this. And linear pair. So those are supplementary and a linear pair. Okay. 1 and 5 are linear pair, 4 and 5 are linear pair. Remember, they're supplementary and have to be adjacent. What angles are congruent? Well, we have angles 1 and 2 here are congruent because we have tick marks saying that they are. Angle 1 and angle 4 are congruent because they're vertical, right? So we have vertical angles. But then guess what? Angle 2 and angle 4 are also vertical because we can substitute in and use that information that says that they're congruent. What else? What else? What combinations add up to 180 degrees? What ones add up to 180 degrees? Combinations of 180. We have, well, angle 1 and, whoops, angle 1 and angle 2. Okay, let's start over. My pen's not working. Angle, nope, still not working. Angle 1, there we go. And angle 2 and angle 3, they add up to 180. Angle, I'm not saying supplementary, I'm just saying add up to 180. Angle 2 and angle 3 and angle 4. Okay. The linear pairs that are listed. So I'm not going to list them again. Yeah, I mean, there's probably more, but I think that's good. We're just, we're just listing a few things that are known that we see here. All right. Okay, can you make the conclusions from the information in the diagram explain TW is congruent to WV? Let's see. The first one, TW congruent to WV. The answer to this one is yes, because we have tick marks, okay? Yes, congruent marks. Okay? Now let's look at PW and WQ. No, there's not. Again, we can't look at fake tick marks and add them, right? We don't know. That came from our prior slide. So the answer here is no, not enough information. We can't fake tick marks. We can't put them in unless they're given. Or there's other information like PW is 5 and WQ is 5. Then we can say PW equals WQ, so then PW is congruent to WQ, but we don't have that information. TV is perpendicular to PQ. Again, not enough information. We can't make assumptions. We can't just assume things like that. Whoops. So I'm just going to paste that information here. No, not enough info. TV bisects. So TV bisects PQ. Again, that would mean tick marks would be here, right? It would mean this. They're not there, so we don't know if they bisect, so we can't say that information. So we're going to say no, not enough info. And W is a midpoint of TV. This one is true. W is a midpoint of TV. That's true because of our tick marks. It has to be a midpoint. So we're going to say yes, yes, midpoints. It's a midpoint because it is equidistant in the center. I want to use the exact language here. Midpoint. Did we go over midpoints this one? We did not. Oops. Okay. Yes, midpoint because it divides a segment into two congruent segments. And that's it. And it looks like we're already at the homework. So we'll do this in class, or feel free to get a little head start on it. And yeah, good luck.